Right. Hello and welcome everyone to Change Notice Unsnapped. Tobias, joined here by Chris. We're going to wait a few minutes just to let everybody trickle in. But while we get started, we're going to share a little bit about our backgrounds here. We'd love to hear from you guys as well. As you file in, post in the chat where you're calling in from and what is the first waterproof product or any type of water sealed product that you worked on. Chris, you want to share yours?
Yeah, actually, so I worked on the Kindle for a long time, and just as I was leaving, we started to work on some waterproof Kindles. So we actually kind of went through like the conformal coating route, but every year I was working on a Kindle, it was like always a request. Can we make it waterproof? Can we make it waterproof? And it was like, well, I don't know. We can't guarantee all this. It's going to make it bigger. And I think finally, just as I was leaving, they started to work on that. But one of the funny things, I remember as a kid, I had this like waterproof watch that I loved and I got as a Christmas gift. And I would just take that thing everywhere. It said it was waterproof, so I would just take it into the shower. I would go into the ocean. I would do all these things. And now thinking about it, I would never do that because I know how hard it is to make something waterproof and how challenging it is. Even once it gets in water, like the seals start to break, they get corroded and everything like that. So we'll take a look and see how the Google team has done some interesting stuff with this Nest product because it sits on the outside of your home and it's going to be subject to the weather.
Excellent. That's interesting to hear. And maybe later on we can talk about the IP ratings and what they really mean versus what marketing claims they mean.
Yeah.
So first true waterproof product that I worked on was the original Apple Watch, the Gen 1. It was a big deal back at Apple because this was the first truly waterproof product that we had developed. And I was specifically working on the health sensor on the backside. And I remember one of the most difficult things is always doing failure analysis on failed glue joints, because if you disassemble, if you take off the back, it's always a very destructive process. And most of the time, you end up ruining part of the evidence of where the failure point was, where the ingress point actually was.
Yeah.
And for this specific module, so if you guys are familiar with the Apple Watch, there's a ceramic back crystal that's adhered onto the housing. And that was done using an HAF, a heat activated film, a high temperature bond. And that thing was very strong. And to do failure analysis, anytime we had to take one of these apart, we had designed this very complex fixture where you actually had to glue a sacrificial piece to the back crystal, heat up the HAF. It was like a couple-minute process, and then it would separate it with a huge amount of force to rip that seal apart. But that was the only way, was you actually had to glue a sacrificial piece with epoxy to that back crystal. And so I have lots of kind of vivid memories of trying to do failure analysis on the back crystals for the Apple Watch. Not an easy experience.
Oh man. Yeah, that sounds pretty rough.
All right, excellent. Let's go ahead and get started. So again, welcome everyone to Change Notice Unsnapped. Welcome especially to those repeat visitors. We've had a couple of these before and have loved the questions and participation. That's my favorite part. So this is our weekly video podcast where we discuss all things electronics, supply chain, and manufacturing. And it's hosted by experienced product design, mechanical engineers. And our purpose here is to build a community for knowledge sharing, support, and continuous improvement. And normally these are run by our CEO, Anna, but for our special Unsnapped edition, it's hosted by myself and joined by Chris here. And we have some exciting announcements as well. So for those that just joined, please go ahead and introduce yourself in the Zoom chat. Make sure that down in the bottom right, you're actually posting it to everyone and not just the panelists. Introduce yourself and tell us about the first waterproof product that you ever worked on. So that's exciting announcement number one. Number two, this is better than ever before. We are actually doing a, I'll call it a raffle, a giveaway. At the end of this session, there's a survey, and if you fill out that survey at the end, we're actually going to give away one of these Nest doorbells, and it's not the one that Chris is going to tear apart. So it's actually a functioning one. So please fill out that survey at the end. In there's actually a new question. We would love to hear, where else do you go? What other sources do you go to learn about engineering, product design, manufacturing? If it's the prepared or ASME or other sources, we would like to hear. And also next week, next Thursday, we're actually having a change notice hosted by Anna on the future of integrity, reliability in the automotive industry. And we're joined by Mike from Cruise. So tune in next week for that one. And with that, let's go ahead and do some quick intros. Chris, you want to introduce yourself?
Yeah, my name is Chris. I think if you've been here before, you know that I worked on many generations of the Amazon Kindle, and then most recently had been working on a medical medtech device. But yeah, my background is mechanical design. Have been working on this ever since since grad school and have loved it. So how about you, Tobias?
All right, thanks, Chris. Tobias' background in mechanical engineering, did product design for about 6 years back at Apple, working on, like I was talking about, 4 generations of the Apple Watch, working on health sensors and optics, and then on touchscreens on the iPhone. And looks like we've got a couple interesting past waterproof products here. Marco worked on the Nike Fuel Band. Welcome, Michael, Ben. I think we're also joined by some of our friends over at iFixit, our repeat attenders. So welcome back, Karsten. So just a quick overview of what we're going to talk about today. So Chris has got the Nest Doorbell here. He's actually going to go through the live teardown. We're going to talk about design decisions, trade-offs. Please, if you have any questions, post them along the way. We love to hear your feedback. And then towards the end, we'll just have an open Q&A for anything else that you guys want to ask. I'm particularly excited about some of these optics that we'll get into later on, as well as the X-rays that we got from our friends over at Creative Electron. So stay tuned for those. And with that, let's dive into it. Chris, take it away.
Sounds good. Just one more reminder, we are giving away one of these doorbells, so fill out that survey before you leave, just so that you'll be eligible to get that. All right, so I'm going to take this thing apart. First, let's take a little overview of this. You can see there's a camera lens here, giant button. On the back side, you got a way to hold this thing, and they include this metal plate, and so it like kind of sticks in here, and there's like a mechanical release button that you use to take it apart or take it off of your wall, because if you're using a battery power, you need to charge it every so often. On the back, it's got USB-C, also 2 wires here so that you can use it as a wired connection instead of just through the battery. There's a little hole, I don't know if you can see this here, for the speaker to come out. That's, once you press this, if it makes a noise. And then I think just on that top is that release mechanism, so you can do that. Also, you can see a little bit of fun Easter egg here. They put some words on the outside. I don't know if you can read that, but it says hello, bonjour, hola, maybe something in Japanese. So they're having a little bit of fun with that one. All right, to take this apart, basically you need to take out these two Torx screws here. I'm using a T5. And these are interesting screws we'll get to in a second.
I would, while Chris is taking this apart, I think one interesting thing we'll talk about is, again, waterproofing. Thank you everyone for posting. Welcome Ben, William, John. Looks like Compology waste monitoring camera, first waterproofing, industrial chemical fluid sensor. From your past experience, what do you guys think is the water seal for this Nest Doorbell? Because this is going to see some harsh environments outside. Do we think it's all glued shut or screws, gaskets? Post what you think down in the comments.
Yeah, so yeah, I'd love to see that. I'm very interested to hear what explosive environments means for those industrial chemical fluid sensors. You can see these screws actually have these little rubber gaskets on the inside. So there's like a little rubbery thing to try and seal that off in there, which is pretty cool. The next part is a little bit tricky. I've taken one of these apart before, so I might have to switch it up. Basically, there's some snaps around the outside here, and this is a very tight gap. So I'm going to take this off camera to jimmy that open, and I'll bring it back in a second. There might be some behind the scenes photo magic here. While we do that, talk a little bit about how this works.
We'll let Chris pry away there. A few shout outs. Welcome back to some of our regulars. Kushal, I think, is joining us for the third time here. We again love the repeat attendees. The questions are what makes this the most interesting for us.
All right, so we got that open.
Sounds like Marco's putting his money on a PSA seal as the water seal. What do we got, Chris?
Well, so there's actually a rubber. Let's see if I can do this. If I can get it out of here. I might need my magic pry tool again. There's a rubber seal around the perimeter. You can see that. And then there is a bunch of looks like some glue seals for like this mechanism and the speaker. And there is some PSA, I'll be honest, on some other parts of this, but that's the main stuff. You can kind of see underneath where those two like power pins come in from the back. Those are also sealed with some kind of RTV or some kind of silicon seal as well. So yeah, this is a little tricky. Maybe we can switch over to the instrumental platform to take a closer look and see this, so we can zoom in. How about that?
Yeah, let me, if you stop sharing for a sec, we'll hop over to the high resolution images. All right, so yeah, for those not familiar, this is our instrumental web platform. Typically, we're collecting lots of data from manufacturing lines to run our analysis on. Here, we're just using it to store our high resolution images. You can see we've got the full teardown in here. And for anyone that wants access to this later, reach out. We now actually have all of the teardowns in one location here. So you can see our previous Sonos and PS5 teardowns as well. So Chris already opened this up. Just a general lay of the land here. It looks like we have a pretty hefty battery. We've got the actual speaker down on the bottom, and then on the other side, it looks like a main PCBA with a pretty large, what looks to be either a shield can or a heat spreader. And then up on top, there's a couple, looks like there's one PCB up here, which I believe has the USB connection. And then this is where the optical module we'll see later on is contained on the other side. And one thing, this is pretty interesting here, that this is so tightly packed. Chris, why do why do you think that this screw and this cowling is so packed in here next to this PCB? That seems a little risky to me.
It does seem, I mean, you know, from our backgrounds in like consumer products that are made to be carried around with you everywhere, I think it would be kind of tough to put those screws right next to some kind of passive or active components there at the risk of shorting. So maybe they're thinking that this one, they're trying to maximize that battery space, because I think the more battery you have, the longer this thing can last. And then maybe they just have slightly different reliability requirements, and that maybe it's a really light PCB. It's, you know, the drop performance is probably not going to be too often or too catastrophic, but that is certainly an interesting choice, because when you remove that screw, I think you could be unscrewing it right into that one of those capacitors there.
Yeah, I think that's an interesting point, is looking at the reliability requirements in test suite. I would imagine a large focus on environmental tests, because
Sure.
this is exposed 24/7 to conditions, as well as thermal and waterproofing are probably the focus. Like you mentioned, likely not a large number of drop events with this doorbell, hopefully. And taking a look at this pretty beefy battery here, we can see it's 6,000 milliamp hour.
That's pretty big.
That's pretty hefty. Just a comparison, if we hop back to our PlayStation controller teardown, we can take a look at this battery, and they actually had, I think it's only 1560 milliamp hour. So the Nest Doorbell is almost 4 times larger than this. And you can also see the PlayStation 5 had this hard shell, which we talked about before. So if you want to go check that out, you can check out that recording on why we think they went with the hard shell versus on the Nest, we just have the bare soft pack that we're looking at right here.
Yeah, I mean, super interesting, the different choices that all of these different companies are making to maximize space, or you know, that one, you know, maybe it's a hard shell because it's going to be thrown around a little bit and tossed around, and they want to protect it. And whereas this one, it's like, you know, it's going to stick on the wall for 6 months or 3 months at a time, and they want to maximize that battery.
Yep. So let's, I've got some theories on this large heat spreader here. We'll have to see what's actually underneath.
Okay.
Also interesting to note, the actual contact here to the speaker is done through these spring pins. And actually, to get a better look, we can actually take a look at the X-rays here that we have of the device. And again, thanks to our partners over at Creative Electron that hook us up with these X-rays, these high quality X-rays each time. So you can see at the side view here, these are actually fairly tall spring pins to bridge that gap that we have here and make contact. So it's actually a pretty unique design that actually has this small rigid spacer to make sure that there's reliable contact.
Yeah, I think that's it's a great way to seal in that speaker, because you know you need the speaker to be facing the elements and able to move the diaphragm around. Some things we kind of explored in the Sonos, and also I think the PS5 controller also had a speaker that had the spring contacts, but in a different manner. So you can take a look, you know, if you get access, you can request access to this project and take a look at the different ways that companies are integrating speakers and systems into their consumer devices.
All right, great. Let's keep tearing this thing down and see what's underneath.
All right.
And again, for those watching along here, let us know a particular module that you want us to dive into. You want us to, you know, talk more about the optics or the speaker or the battery, and then we can make sure that we'll touch on that.
All right, so I'm going to take out this module first. Just those 2 screws, I think, are what hold it in place. Again, I'm using a T5 Torx bit. I think this now can pop out. And so that's the whole battery housing. You can see those the contacts and this seal for those different elements. I think this one I actually need to switch bits. There's a Phillips bit here. Not quite sure exactly which one it is, but I'm going to use a J0 here. So I got one screw, and then I have to flip this up a little bit. There's a little stiffener that holds, looks like a board-to-board connector in place. So I can take that out. There it is. And then this is actually kind of taped in place with this other shield can here. So let me take that out. And there's, looks like 2 or 3 or 4 screws that hold this section in place. Oops, got the wrong screwdriver head. So I can take this one off and this one off. That's all I need. And there's, so this shield can kind of flips back, and you can see, oh, there's a big glob of thermal paste there. Trying to see if I can pry this one out. There it comes. Just unhook that one. Okay, so we got camera module, and let's see if I can take this work. Yeah. Well, we can just take this module off. It's all taped together. Well, we can leave that one here for right now. No, I see it's glued together. There it is. So there's these 2 modules here. This one is interesting. It's got 2 other screws that hold, looks like a little plastic carrier in place. I think these are the contact points for those, that wired connection. So there's like a couple of springs here. So I can remove that and we can get a little bit closer look. See how they did this one. And I think, let's see, oh, this might require a slightly smaller screw.
I'm excited to look at those optics as well.
Yeah,
I'd love to, let's hear from the audience as well. Looks
okay.
like there's the main camera, and I think there's another small optical module on top. What do you guys think are the sensors that are required for this Nest Doorbell to work? Looks like there's another sensor up top there that we can look at, as well as what the actual lensing looks like on that outer enclosure.
So before we get to that really quickly, I'm just gonna, there's like another little board-to-board that holds this thing in place. So there's this plastic housing and this flex with some interesting spring contacts there. And then this is the USB board. They probably have to run a bunch of power through this. So, you know, it's a pretty compact little board assembly that they made here. Pretty cool. And I think it hooks on and screws on, so it's got some positive features, and then that board-to-board connector just kind of smashes in at the end. So that's the way it would go.
What do you think the assembly order there was, Chris? Was it goes flex to the molded plastic part, and then the PCBA is clipped onto the top, and then the screws are inserted?
Yeah, I mean, I think the springs first to the plastic molded part. It looks like there's maybe some heat stakes or some snaps, and then these little springs have some little raised areas that will contact these pads. And yeah, so I think it's a hook, and then kind of snap down. So I felt that positive contact, and then they screw it in place to make sure that that connection doesn't come loose. So pretty cool little module. And then this is the one that I think people are probably maybe more interested in. So what I remember, I noticed that this one, I could actually, there's like a screw here holding some kind of other module that's powered. So we can take a look at that. And I think this gasket actually comes off, so you can get a better look at that, that sensor. So that looks like an ambient light sensor. I think this one I might have to, oh, I am already on the T4.
Yeah, I'm thinking you're right that that's probably an ambient light sensor, though it's a little bit beefier than most ALS sensors that I've seen before.
Yeah,
I'm
well, I
wondering.
think they probably had a little bit more room than you or I had in our product.
Yeah.
And especially depth in Z, right? It's kind of a really thick one. Maybe they have a, you know, they want a wider array, like a wider field of view, or just more light. So I can actually pull this. This is really interesting. I can pull this, what looks like, I don't know, like a filter or something out from behind the camera module itself.
That's pretty cool. What so that is a powered filter. What do you think what type of filter do you think that is?
Yeah, I mean, I think some people are saying that maybe this is a powered IR filter. One of the things, because this camera has to work kind of 24/7, maybe it's being used at night to filter out non-IR light, because you want to see some of the IR reflection from, I think there's some LEDs in here that kind of light up things at night. And then during the day, maybe you don't want to see any of those IR things, because it's going to impact, you know, what you're seeing, the regular visible spectrum. So that's kind of interesting. And then I guess I can take these two screws off here as well. And I think maybe this whole camera thing will come off. And then we can take a closer look at instrumental, just because I think it's a little too small to see here. But that whole lens structure comes off, and you can see the bare sensor, which is pretty unusual. I think usually these things come as modules,
wow.
especially for cell phones. But yeah, you want to switch over to instrumental? Maybe we can take a look.
Yeah, that's pretty surprising that that's held on by just one screw. I'd be very concerned about the actual assembly of that.
I think there are two screws, but yeah.
Two screws. All right. Well,
so that's fine.
Let's switch over. Let's look at the optics for a second. We do have some good questions from Oren on how this design compares with the previous Nest Doorbell design that did not have a battery. What types of changes, trade-offs do we have to make? Let's hit on that in 1 second. Looks like Chris is also agreeing on the IR filter. I think that's the powered IR filter, which is pretty neat. Let's pop in. And question on what is it, waterproofing, which I think we can actually see here. Waterproofing between the lens and the sensor board. So there's a couple different water seals here. So we take a look. This is the lens assembly that just pops off. There's this O-ring which water seals. I believe this water seals against the main housing.
That's right.
And then underneath there is another gasket here. I wouldn't say, I think that gasket is actually loose when I had it on mine. Chris, can you confirm? I don't think that's...
Yes, it is loose. It's actually popping up on mine right now. So
yeah, it probably provides some environmental protection. I would guess it's more for dust and particles than actual water ingress. Yeah. Again, this is a really interesting design manufacturing decision to have this be actually a board level subassembly instead of coming in a completely enclosed submodule. I would think this would be very high risk to actually get some particulate, depending on if this was done in a clean room on top of this sensor. And again, would love to hear from everyone in the audience here. Why do you think that they went with this design decision to assemble it? Maybe it was at final assembly. My best guess would be they had a small little either clean booth or a clean room where they did this subassembly, because you have to have a much cleaner environment than the standard FATP line to avoid any particulate here. What do you think, Chris? What do you think the advantages are of leaving this modular?
Well, I think we have some friends from iFixit here who would say that's maybe to have some reparability and some ability to switch out different lenses and different modules. But yeah, I mean, I think I did take a look at a previous teardown of the previous generation, and they had at that time also used a separate module. So maybe they're more familiar with this design. I think it also allows them to have a much, maybe they're creating a custom lens for their system to get like a slightly wider field of view than maybe you would get on a regular, that kind of comes from the factory. So maybe they have to create a separate module for themselves. I don't know. What are your thoughts?
Yeah, I think probably the biggest advantage would be flexibility of swapping out designs to different lenses, especially during the NPI phase.
Yeah.
If you have to have a module completely designed and assembled upstream, that is many weeks out. You have to lock that design way ahead of time. With this, it leaves more flexibility. Try a few different lens configs. Maybe try a few different vendors for this IR filter. So really, it's more design flexibility at the risk of contamination during the assembly here.
Yeah.
We've got
seeing a couple of comments here saying that that top sensor might be a PIR sensor. I guess it's a pyroelectric infrared sensor, maybe a motion sensor.
That's actually, yeah, that is interesting. It could be just a passive IR sensor, because I believe the doorbell does have a feature where when you approach, it wakes up.
Mm-hmm.
And sometimes that's done through, I know there are infrared lights on here as well. And so I'm not sure if it's actually emitting those infrared lights to use as a standard prox, or maybe this is just a passive one.
Yeah.
But Chris, I think Chris, who had a good point here? Yeah, Chris had a point about what does the lens, what is above this? Like, what does this actually face to the customer? That'd be interesting. Let's go ahead and take a look.
I think you got some pretty good shots of that in your system. That would be really hard to see here.
Yeah, let's just actually look at the enclosure of what that is. So that's way back on the front side. We can go through. So this is actually what's covering that PIR sensor is this black housing. And you are correct, Chris, that you can't actually see through this with visible light, at least in the standard light. But if you shine, I was shining a light for it, and you can actually see a lensing pattern.
That's cool.
Which is pretty neat. I believe this is a Fresnel lens.
Yeah.
Which have you worked with Fresnel lenses before, Chris?
We talked about them a little bit when I was working, but we never. Let me think. We might have used one when we were doing some IR like touch things on the Kindle Touch, but yeah, that's pretty cool. It sounds like maybe you have some more actual experience with Fresnel lensing.
The Fresnel, you have to resist the temptation to call it the Fresnel lens. Yeah, the Fresnel lens. I actually worked a good deal back on the Apple Watch. There's actually a Fresnel lens on the heart rate sensor on the back. And for anyone that's not familiar, a Fresnel lens, essentially, if you take a standard spherical lens, you chop it up into these conical sections, these concentric sections. You chop it and then you compress it down. Then you can create a very thin lens with a similar effect. There's some losses, but you can create similar lensing effects in a very small Z space. And it looks like they've got, again, maybe 6 different lenses here. And my best hypothesis with this knowledge from Chris on this being a PIR sensor is this is to help gather and focus the ambient light that's coming in so that it can actually detect at wider angles rather than standing just in front. So this is actually a pretty neat design feature that you don't actually notice from the outside.
Yeah, and that leads us to another interesting point. I think someone here is saying that maybe that material is the cosmetics are pretty important for the Fresnel lens, and maybe we were wondering earlier why there might be this split between the top half of that that kind of black ring and the bottom half. So maybe they were really focused on getting that the molding parameters, and the thickness of that dialed in for the lens, as opposed to the more common sort of IR transparent section at the bottom. Really
Yep,
cool.
yep. It's and again, lots of great comments on the Fresnel. Yeah, Marcus is asking, how is it actually manufactured? How are the cosmetics on it? It is very difficult to mold. This one looks like it was co-molded with this exterior black plastic, which in my experience, it limits what the actual sharpness is on the radius of each of these ridges based on your molding tool and all the ridge spacing. Luckily for this one, you can't see it from the outside, so the cosmetics are a little less apparent. But yeah, this one looks like probably just a molded plastic. I have seen, again, on the Apple Watch, we actually used a lithography process to get much sharper ridges. And if you look on the back of the watch, you'll see that the cosmetics are actually a big deal there, because it's used to obscure what's behind it, because it's actually visible, versus here is just IR transparent. All right, let's see, another question from Oren on why are there 4 different Fresnel lenses. I actually see 6 different lenses here. I've got some theories. Chris, what do you think?
I will defer to you and maybe the experts on that. It looks like Chris, his experience as a co-founder at Canary would definitely, a security camera would have some ideas here. But yeah, I guess just trying to concentrate different, getting a wider field of, getting a wider field of view so you can see from different areas, because you don't know which orientation this camera is going to be installed in. It could be installed on the right side of the door, the left side of the door, it could be angled slightly. So you want to get as wide a field of view as possible.
Yeah, I would agree. I think it's likely to optimize the field of view where you can sense a person. So probably optimizing some lensing from the left, some from the right, top and bottom there. All right, great questions. Another question from Marco on where are the infrared LEDs? And I think we're getting there next, so we can actually take a look. Let's see, anything else, Chris, before we keep going that we want to talk about on the back side here? So again, back to our camera PCBA, our PIR sensor. Again, little gasket around here. That kind of reminds me of the gasket from what was it? The Sonos?
Yeah, what they had there.
Yeah, back in the Sonos, we had a gasket. This one was not for a sensor. This one was for the emitters, for the LEDs.
That's right.
So slightly different purpose, but it does kind of remind me of that.
Yeah, it's so cool that you can go back and forth from different, in this case, different products, but in production, different devices, to see if there was some gasket was offset or something like that. So you could really see each device in production or in pre-production, which is really cool.
Yeah, that's one of the things we see, honestly, with a lot of our customers. Things like gaskets that are manually placed, these thermal pastes, which again are also manually placed, and just inherently have a ton of variability. And so that's where the instrumental system is great at just picking out that anomaly. Thermal paste here, again, this connected on the back side, I believe it was to a shield can, correct? If we look,
right, yeah, to that shield.
We go back here,
that metal shield.
Connected here. So again, you can see big focus for thermal management on this device, because again, this could be in the sunlight for 12 hours or more per day. And so thermals is probably a very significant concern for the design here.
Yeah.
All right. we can hop back to, there was a
Yeah.
question on what design deltas do we see from the original Nest Doorbell to this one. Now I know we haven't actually torn apart the original Nest Doorbell, but we can comment on likely some of the trade-offs that they had to make. Chris, did you have any thoughts?
I did I watched a teardown that someone else had done. I think it was CNET, and there were some pretty interesting, very good things that the Nest team has done. For instance, I think the previous one was kind of more of a mess. There's a lot of thermal grease or glue kind of all over the place. There were like multiple different types of modules and several different boards. So just reducing the complexity of the assembly, I think, got them a lot. Also, they had like a faceplate that was just kind of glued on, whereas this one you can actually more easily get in with just the screw and the snap. So it's easier. So they probably increased their yield if there was a problem inside. They also were able to reduce the size of the product by quite a bit. Even though this now has a much bigger battery, they just kind of smush it all in and put a lot of components on the main board here. And I think they reduced the number of screws, the volume of the packaging, the number of shield cans they had. They used to have 2-part shield cans, which is, double the component cost, because you got to make a shield and you got to make the lid as well. Whereas this one, I think it's just kind of single piece shield can. So they did a lot of great engineering to reduce the size and the complexity of the product. And I think they've done a really great job here. So it's really interesting to see, from Gen 1 to Gen 2, how much work has been done to make this product better. I mean, they got new technology, but also cheaper. And I think this product retails for $179, whereas the original was $299. So that's over $120 in savings for retail, which means they probably got a lot of that at the COGS at the BOM cost.
Those are great insights. I think you covered a lot of hypotheses, which I think are probably pretty accurate. Let's keep going through here. We still got a few more exciting things.
All right.
Again, a few reminders to everyone else. We are giving away one of these Nest doorbells. I'd be curious to know from everyone here, what do you guys have right now? Do you guys own a video doorbell, or is this a new category for you guys? So let us know if you already own video or any type of security cameras.
Yeah, and which ones do you own? Is there a particular one that you think is doing well, or that you like, or are there things that you're excited about for this product? I think Ring. I don't know if there's Arlo, a couple other competitors out there. I think someone was asking about where the IR LEDs are, and there's a secondary little board. I don't know if you can see it under here, where this flex cable, and the flex cable just goes from here to here. So this is a little tricky assembly process. I might have to use the pointy end of this stick to remove this FPC. There it goes. And now I can't take this board out until I do a couple of things. One, I have to remove this. Looks like they have a stiffener or spacer here, and this is the thing that those 2 initial screws actually screwed into. And then it looks like there's some compressible material here. And then, if I'm not mistaken, I think this is actually glued on around this button to provide additional sealing as well. So I'm going to try to work on that while we talk about or answer some other questions that people have. Let's see if I can get in here.
Let's see. So it looks like we've got Marco's got a Ring. Okay. Looks like Oren's got a new category. He made his own security cam. Now that's impressive. William has the Ring doorbell. Excellent.
Looks like this is like a little light guide. There's some LEDs that you might be able to see in here. So I think the Ring kind of lights up when you're operating, or when you press the button, or just as a LED indicator. Okay, I think that's all I need to get out here. And then this side is actually a little, it's like a snap in here.
It looks like that blue rubber piece, Chris. Is that just a vibration damper that makes contact with the speaker on the other side?
I think so. I think that's to prevent sort of vibration. Like if they didn't have that, it might cause some internal vibration. So this just kind of dampens it against there. But you know, if I could be wrong, but that seems like what it is because it's kind of raised proud of all the surrounding plastic. Let's see that come out. There it goes. All right, so then I think you have to, okay, so this one came out. It's stuck there, but there is a actual pretty beefy sort of weather sealing adhesive that goes around this. It looks like they used a board-to-board for that camera sensor. And here's those like spring contacts we were looking at earlier, so they're pretty tall. But I think you got a pretty good picture of this on instrumental. Maybe we can take a look at that from here now that I've got this out.
Yeah, let's hop over.
All right,
If you
good.
can stop sharing for a sec. We've also got some more, I got a good question from Arthur on the longevity of the product coming up soon, but let's hop all the way back down to the main PCB. All right, so this is what we're looking at. Let's see. Let's just take a look at this main PCB, and we actually so this is the side that I think you're looking at, this side here.
Okay.
And I don't think it's pretty tricky to get this whole panel off here. I don't know if you want to start taking that off, or let's just
I'll give that a shot, but maybe
we'll give you a jump start on that. But those things are on there pretty tough. So I think as Chris was pointing out here, so we have the LEDs on the button, and these I believe are just to light up the actual button. I believe when a user is actually close by using that prox sensor to light it up. Again, big shield can on the back. And if we take these off, you can see, so this is on the back side here, where they actually have the processing unit. There's actually a hole in the shield can with some thermal paste to go directly to the thermal tape on top, which is interesting, instead of putting thermal paste directly to the shield can here. That's an interesting design choice.
Yeah, I think sometimes when you see that, they're actually reducing the size, like the thickness. Like, you know, this is a pretty thin product, so they kind of put a cutout in the shield to take it from sort of this sheet metal to a copper tape with a carbon heat spreader on it, that which can kind of spread that heat more evenly across and distribute across the rest of that metal area. And then I think it seems like that's kind of what is touching on the other side of the board as well, maybe. I'm having trouble getting this thing off.
Yeah, so what Chris is referring to here, again, big focus on the thermals, because this is, you know, battery powered, sitting out in the sun all day long. If you look on the other side, then where they had this similar large heat spreader, if you look underneath, again, this was a huge pain to get off. There's a large amount of PSA holding it in place, as well as the only thermal contact point here is directly on the back side of this processing unit. So they're really focused on dissipating heat from this one processing unit right here. It dissipates all the way through this side, as well as throughout this massive heat spreader on this side. And again, a bunch of grounding. These are small little conductive foams. It looks like they wanted to really make sure there was a consistent grounding path likely for antenna performance.
Yeah, I'm just gonna give up. I'm not gonna take this apart. I think you got a better picture of that than I did, than I can. But that's a lot of adhesive, and it does look like that's a conductive seal around the outside of that, probably the main processor, because I think they have to do a bunch of are they doing AI processing or machine learning processing to kind of take a look at identifying different types of people. I think it can recognize friends or family that have been part of the system, which is pretty crazy if they can do that on the device itself. But yeah,
that's impressive, and that's probably what's taking up a lot of the power and the processing. So I think a couple of people were asking about what's actually under the shield can, what type of SoC they're using here. That might have to wait till a bonus episode, because this thing here, it's actually SMT'd down to the board, I believe, right, Chris? It looks like it's not a snap-on shield can.
It is an SMT. It's a single piece, and it's soldered all the way around. I don't have my soldering gun here. Soldering iron. Maybe we can do a follow-up blog post where I kind of hack that apart and open it up. I think the bottom shield, I've got to say, I think is the wireless one. You can see some of those. You can see a couple of, if you go back to the other one, you can see a couple of the isolated traces and the sort of 50 ohm lines kind of going down to the bottom area. So that must be for the Wi-Fi. And usually you want to keep that shielded separately from your processor. But yeah, unfortunately, we'll have to come back to opening this thing up to see what's underneath.
We can, Chris, how about this? If you hang out, we'll switch over to a little live Q&A. And if you want to hang out, I'll take the one that I have right here and go get some aggressive tools, and I'll rip it off at the risk of destroying this if we really want to see what's underneath. Looks like Oren wants to go back to our X-ray here. We might be able to see a little bit about what's going on under the X-ray.
Yeah. Did you get a different view of it? I think that one is just kind of, can't see much.
The top view, we can see. So I think this is the small can underneath.
Yeah.
You can see, you almost need to increase the contrast here, but we can see a bunch of little components, and I'm assuming maybe a larger SoC somewhere up here.
Probably like a Wi-Fi chip, Skyworks or something like that.
Yeah. Here we can see, looks like a couple rows here, some passives, and then this looks like, kind of hard to see, but this looks like the large SoC processing unit.
Yeah, that makes sense.
And let's see, anything else interesting? So here's our PIR sensor. You can see all the connections being made. Camera here. Again, here's that interesting lensing mechanism, that IR filter, which I still think is pretty neat.
Yep.
If we go back down.
Oh, that's cool. You can kind of see that there's like a spring. If you can, I think the way that this kind of attaches to the metal backing that goes to the board or goes to the wall of your house, there's like a little spring-loaded mechanism there that I think forces it up once you release it. So that's really cool. You can see that.
And we can take a quick look at the side here. Yeah, we took a look at the spring fingers.
Oh yeah.
There was another request earlier on about, can we do a deep dive teardown of this actual mechanism that locks it into place? It's a pretty cool security mechanism. We'll have to see if we can get all the way torn down there. But I think it rotates to lock into place against the panel, the panel that's mounted to the wall. Is that correct, Chris?
I don't know, actually. That's possible. I think that there is a spring-loaded mechanism. I think it's just really embedded all the way through that. And then I guess the screws also kind of hold it in place. I'm not sure how that one is made, but I mean, obviously, if that was like the weakest link, you could just rip this off the wall, which you wouldn't want. So they must have done a lot to keep that embedded.
It looks like these two pretty hefty screws that go through. You're right. I'm not actually sure if this rotates because I don't see any actual actuator. I think it's just like you mentioned. There's a special tool to release it, I believe. So I think it might just clip in there via a clip mechanism and then
on the other side, I think, where the mechanism would be, if you can see it or not, I don't know.
And then let's just take a look around here. Yeah, what's interesting, again, this is the main PCB and the battery. There's actually a pretty significant gap between here. I would guess, again, thinking back to the fateful days of the exploding Samsung phones, which I believe the leading hypothesis was there was not enough space designed around it for geometric expansions, thermal expansions. So I would guess they left a pretty significant buffer here for this battery to swell during different charge states and during different thermal conditions. That's my bet.
Yeah, that makes a lot of sense. And also probably an air gap in there for distributing that heat from that main processing unit.
Yep. All right. Excellent. Well, we're almost coming up on time here. We got a lot more great questions. Let's actually switch over to the off the record portion. We can have anyone come up on stage, ask some questions, and maybe we'll even dive into that shield can underneath. So before we log off, again, thank you for joining Change Notice. Few final reminders: fill out that survey at the end. We love to hear your feedback. Giveaway for that Nest Doorbell based on that survey. Change Notice next week on reliability in the automotive industry with Mike. And yeah, thank you all for joining. Let's, if the powers.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.